Studying adsorption, huh? Got a big test coming up? Staying up all night studying? Let's see how we can make sure you get some shut-eye. At first, adsorption looks like it's just stuff sticking to other stuff. But if you take a closer look, you'll see that there's more to adsorption than that. Adsorption is the adhesion of particles on free surfaces. Adsorption happens when atoms, ions, or molecules attach to the surface of a substance without entering it. They hang out on the surface. An example would be chemicals in a liquid sticking to a solid surface. If we zoom in closely, closer, almost, there! You've probably seen an image like this in your textbook before. Ions, which are chemicals with a charge that are attracted to soil particles. It's a bit more complicated than just stuff sticking onto other stuff. The outer sphere and inner sphere complexes are attaching in different ways. It looks like some of them can easily be knocked off or exchanged with other compounds in the solution, while others are holding on tightly. You can clearly see at this view how the hydration sphere surrounds the outer sphere complexes and not the inner sphere ones. Can you see what the difference is? Water! We call it hydration. Water is dipolar, which means a water molecule has a positive side and a negative side. An ion bound by outer sphere adsorption is surrounded by a hydration sphere, a collection of water molecules that are physically attracted to the ion because of its charge. Hydration spheres can form around both positive and negative ions because water has a positive and negative end. We see water molecules gathering around a cation and an anion, clearly showing the different ways they attach based on polarity. Opposites attract, just like with magnets. Since water has a positive and a negative side, it can align with either type of charged ions. This same physical force attracts the water molecules, with the ion in tow, towards the charged solid surface in soils. The water is acting as a buffer between the ion and the solid mineral surface. The ion sticks to the surface, but only loosely, so it's easy to remove again. This is what happens during ion exchange. It's like a chocolate-covered pretzel. The chocolate is stuck to the pretzel, but you can easily chip it off, although that seems like a lot of work to eat a plain pretzel. We say hydration sphere, but the ion doesn't need to be completely surrounded. Even just one water molecule between the ion and the surface is considered outer sphere adsorption. Outer sphere adsorbed ions are easy to remove. They can be knocked loose by physical force, readsorbed back into solution, absorbed by plants, or even leached away and replaced by other ions with a similar charge. Since this adsorption process is entirely physical, it is called physisorption. Without water, though, something different happens. The ion shares some electrons with the surface. This is called a covalent bond, ligand exchange, or anion penetration. This means that a brand new substance forms at the boundary of the surface. The formation of a strong covalent bond during adsorption creates a new chemical compound, so this process is called chemisorption. Monodentate inner sphere complexes attach at 1 point. Bidentate complexes attach at 2 points. Polydentate complexes attach at 3 or more points. In adsorption, the more dentate links, the stronger the bond, and the harder it is to free the adsorbed ion. And in chemisorption, you don't even need a charged surface. It's like baking a cake. You start out with flour, eggs, milk, and sugar, but once you bake it, you can't separate the ingredients. So to review, physisorption is like the chocolate-covered pretzel. Chemisorption, which is fusion, is like the chocolate cake. Anyway, this new substance locks the ion away, so it can't be knocked away from the surface, or taken up by plants or bacteria. The rate at which these happen is different too, which is why we have to run so many adsorption experiments. Outer sphere adsorption is a physical process. It's fast, and all it needs to occur are dipolar molecules like water and a charged surface. Inner sphere adsorption is a chemical bond, so it only happens in more specific circumstances. You've got this. With the naked eye, adsorption may look like just one process, But when we get down to the molecular level, we can see it's actually very complex. These two processes have a lot of implications. Whether fertilizer and nutrients can be used by plants, what percentage of impurities can be caught by a water filter, and much more. It's all part of the wonderful world of adsorption. Oh, sorry. Now you can get some well-deserved sleep.